A very good morning to everyone out here. I am Vinay and I'm coming live for you all from Mumbai. Giving a short introduction about who I am. My name it is Vinay Bajaj. I have been a teaching faculty since 2014. My subject expertise are mathematics, accounts, economics, and business studies. Bachelor's in accounting and finance. I've done my masters in commerce from Mumbai University. I have also cleared CS Foundation Level 1. I am soon about to pursue Level 2 as well. It has been really a wonderful journey so far, and I'm looking forward for such wonderful experiences here with Unacademy as well. So I am coming live for you all, for especially for all the grade 10 students, on a wonderful topic and a very important topic which will help you to score full, which will help you to understand that particular topic in a better manner, and you can use the theorems, you can use the applications, you can use the properties in other geometry related chapters as well. All right, so coming back to the core for the day, we will talk about circles. All right, we'll be talking, understanding, learning, and solving a few applications with respect to circles. This is a very important topic for your grade 10. Okay, it is a very small topic. Take the advantage of its size. It's small, the concepts are not that huge. You just have two or three or four theorems to understand, and the applications based on those set of theorems. So whenever you sit back with this particular chapter, all right, you have to keep in mind that you have to secure your 4 marks. So now this complete 1.5 hour session will make you, or will enable you, or will boost up your confidence that you will now be able to secure that 4 or 5 marks particularly. So this chapter, the weightage of this particular chapter, it comes in question number it comes in your section B, okay, for 2 marks, and it may have 1 mark MCQ as well on it, and it may come a lengthy sum, a bit lengthy sum may come in section C, that is for 3 marks. All right, so overall when we take out the average, this chapter has approximately 3 to 5 marks of weightage. Okay, 3 marks is bare minimum, that one sum is sure in section B, one MCQ is sure. It will be always application based. Very rarely proof questions are asked. It will always be application based, and you have to find out the missing values which have been asked in the question. How you will find out the values? See the session completely. I'll be briefing about all the details with respect to circles. Before starting, I would like to tell you all, okay, if you all enjoy this video, after watching this video, if you feel that yes, it was really helpful, I can learn and I want to learn all the subjects, or particularly maths, in this manner, don't forget to subscribe. Okay, don't forget to subscribe Unacademy. You can use the referral code on the screen, that is VB19. It will give you a straight 10% discount for your subscription. Make sure if you enjoy that you do not miss this chance. Okay, so let's start with today's topic, that is circles. Now, whenever I hear the word circle, it always comes to my mind that right from the coin in my pocket to the biggest star in the solar system, right, that is nothing but the sun, we all are surrounded by circles, okay, or circular shapes object, maybe be it any. So whenever I know that what a circle is, okay, how does it appear, what does it look like, okay. So when we read the definition on the definition given on the screen, a round plane figure. Now why a round plane figure? Because it is not having any sharp edges. It is round in shape, curvy lines, okay, one curve, not curvy lines, one curve. So we say it is not having any sharp edges, or it is not having any straight line on the edges, that is nothing but on the boundary. So a round plane figure whose boundary consists of points equidistant from a fixed point. Now that fixed point is nothing but the center of the circle, okay, from where we start drawing the circle, that is nothing but keeping the point of the rounder and then rotating it, so we make a circle. Now all the points which are drawn from the circle, that means they are starting from the center of the circle to the end of the to the boundary of the circle, that is nothing but the circumference, they all are equidistant in nature. This is one of the smallest property, or one of the easiest property to remember of a circle, that any line drawn from the center of the circle to the edges or to the boundary of the circle is known as a radius. We'll be coming across that particular term in the next slide. So now let me introduce you all to the family of circles. We'll be just going about understanding each and every term related to circles, basic terminologies through by which I will be able to use them when I do the sum. So listen to the next part of the session very carefully. So we have a circle in front of us, right? Now there's a white dot in the center of the circle. I am sure that you all might have answered this. It is the center of the circle, all right? So the center of the circle is the point equidistant from all the points of the edge, on the edge. So n number of lines I draw from that center to the points on the edge of the circle. All will be of the same length. All will be of the equal length. Moving forward, the next thing, very important thing, is the chord. A chord of the circle is a straight line segment whose endpoints both lie on the circle. That means the place from where it is starting is on the circle, the place where it is ending is on the circle. There can be n number of chords in a circle. There is no particular fixed number that it has to be limited to that number. Okay, you can draw n number of chords in a circle. Moving on to the next part, the radius. You might have heard this term many a times when you study maths, when you study particularly geometry and you are studying about the topic circles. So any point on the edge of the circle, a line drawn from the center to that particular point is nothing but the radius. There can be n number of radius also in the circle. Okay, no limit for drawing the number of radius. For example, when we see the chakra in our tricolor flag, we say there are 24 spokes or spikes there. Okay, now those spikes are in this manner, but if we draw straight lines there, it is nothing but we say that that is the radius of that particular chakra. So that is how in circles also, the line starting from the center to the end point, any end point anywhere on the circle, not in the circle, okay, on it should be on the circumference, is nothing but the radius. Perfect. Then a diameter of a circle is any straight line segment that passes through the center of the circle and the end points lie on the circle. We say that the diameter is the longest chord. Okay, which is the longest chord? The diameter is the longest chord of the circle. Whenever I am talking about a diameter, we say that it is twice of the radius. Yes, because radius is half. Again, we extend the radius to the another point, but it should be straight line. It should form a 180-degree angle. Okay, that means it is the diameter of the circle. So we say that the diameter is equal to 2 into radius, that is twice of radius, or we say radius is half of the diameter. Alright, so whenever you see the question that which is the longest chord in the circle, it's the diameter. Diameter is the longest chord since it is passing from the center of the circle. So any chord passing from the center of the circle, same side, because it is practically impossible. So we say that that particular chord is nothing but the diameter. Meter. And in the previous slide, we did introduce circles to you. A quick recap of the previous slide. I want you all to answer in the chat, so you can answer me in the chat as well. So let's quickly start. Dash is the longest chord. Is the longest chord of the. Alright, the answer to this question is diameter. The diameter is the longest chord of the circle. Let's move on to the next fill in the blank. The boundary of the circle is known as dash. Boundary of the circle is known as dash. That is, the diameter is the longest chord of the circle. The boundary of the circle is known as circumference, and dash of the circle is a point which is equidistant from the points on the circle. That is, the center of the circle is a point which is equidistant from the points on, from all the points on the circle. So we are clear with all the basics. Yes, now we have one of the most important things, that is Pythagoras theorem. I am pretty sure that every 10th grade student knows what is a Pythagoras theorem, what is a Pythagoras theorem, how it is calculated, and what is the use of this particular theorem, or where to use it. So we have a right angle triangle. Now what is a right angle triangle? Of course, it should have one angle as 90 degree. One angle as 90 degree, and the side opposite to the 90 degree is always known as an hypotenuse. It will be the longest side of the triangle. Alright. So we have ABC right angle triangle at angle B, and This is the particular equation which is formed by using the details of this triangle. That is nothing but AB square plus BC square is equal to AC square. AC is the hypotenuse, AB and BC are two other sides of the triangles respectively. So the equation framed is one side square plus other side square is equal to hypotenuse square. Now where we will be using this? Of course we'll be using this in the applications to find out the missing angles or to find out the sides whenever we see an angle in the semicircle. Now this particular line, that is angle in a semicircle, we'll be coming across, we'll be talking about this in the next few slides. So now let's all of us travel to the world of circles, where we'll be discussing about the properties of circles, the theorems on circles, and we'll use those theorems in finding out the missing values for the said applications. So now the seats are moving and we are ready to just fly to the world of circles. Well, the first thing which we should know about a circle or a part of the circle is a secant. A secant is a line that intersects a circle in exactly 2 points. Okay, so we have a chord, say we have a chord in the circle. Now that chord extends outside, both the ends of the chord extends outside the circle, forming a 180 degree forming a linear pair. Okay, that particular line is known as a secant. So any line which is intersecting the circle at exactly 2 points, not more than two, not less than two. Okay, it should intersect on 2 points, only 2 points, not more than two, not less than two. Okay, is nothing but a secant. The most important thing, tangent. Now all the theorems with respect to grade 10 will revolve around the tangent, the word tangent. So please understand this, the importance of this word, the importance of this particular family member of circles. A tangent to a circle is a straight line which touches the circle at only one point. As you see in the diagram, we have a circle with the center O. There is a radius and there's one line touching only the end of the circle. It only touches the end of the circle, that too at only one point. So we say the tangent to the circle is a perpendicular to the radius at the point of tangency. What is the point of tangency here? Where the radius is meeting the particular line. So the line, this line, the slant line is nothing but the tangent. The tangent can be the perpendicular or the radius can be the perpendicular. However we say it, there is a 90 degree angle formed between both of them. Now how this 90 degree of angle is formed between them, we'll understand that with the help of a proof of a particular theorem. Angle in a semicircle, as a few slides before I mentioned, we will be talking about that particular thing in the coming slides. So if an angle is inscribed in a semicircle, that angle measures 90 degrees. When I say that, I do not mean that the third vertex of that particular triangle which is inscribed in the semicircle should or can be inside the circle. No, when it is inside the circle, this angle in a semicircle theorem does not apply to it. When the third vertex is also on the edge of the circle, that is, the point should lie on the circle, on the circumference, then only we can say that that particular angle will be 90 degree by using the theorem of angle in a semicircle. Moving forward, we have the demonstration on your screens that AB is the diameter. Okay, AB is the diameter. Now always remember, the diameter divides the circle into two equal halves. The diameter of the circle divides it into two equal halves. So we have taken the upper half, we join the triangle. It can be, the C point can be anywhere in the upper half of the circle. Okay, it is not necessary you have to take it on the top, it can be anywhere. Be it anywhere if it is on the edge of the circle, if it is on the circumference, if it is on the boundary and touching the two vertices which are forming the diameter, that is nothing but passing from the center. That third vertex which is on the edge of the semicircle is the value will be 90 degree by using this particular theorem. I hope everyone is clear with this theorem. Are we good to move forward? Alright, so here is the theorem. Now I understand and I completely understand and know that the students have the same feeling as the letters here on your screen are having. Okay, see, to remember a theorem is difficult. You may understand the logic for now, okay, you may understand it for now, but how to remember it? How you will remember it? It is nothing but to understand the logic behind it, how that proof has come up. If you understand how that proof has come up, you'll be able to use it anywhere whenever you have a sum with respect to circles. So let's quickly understand every theorem in detail. So the first theorem which you have for your syllabus is the tangent at any point of a circle is perpendicular to the radius through the point of contact. Whenever we were talking about tangent in the previous slide, okay, we did understand that any line passing, any line touching and passing through the circle, okay, touching only one point, and the radius drawn from the center will always form a 90-degree. Okay, that was theoretical. Now how to understand it? I will be proving it for you guys in the coming slide. That is, we have a circle with the point O. Okay, so O is the center of the circle, OX is the tangent drawn to the circle, and OP is the radius. Okay, so again repeating, O is the center, XY is the tangent, and OP is the radius. We have to prove that OP is perpendicular to XY. That is the tangent, that is the tangent theorem all about. So as we start proving, we take a point Q on XY. Plot anywhere on XY a point. You can take it as any consonant. Okay, I have taken your Q. You can take any consonant, whichever you want. So take a point Q on XY and then other than P, and then join that particular point. So I have here joined OQ. If I again repeat it, see, I'm joining O and Q. So now Q is a point which is outside the circle on the tangent. So practically and logically speaking, the length of OQ will be greater than OP, since OP is a point which is only till the edge of the circle. I repeat, since OP is the point only till the edge of the circle, whereas Q is a point outside the edge of the circles, outside the edge of the circle. So when I join OQ, I say that the length of OQ will always be greater than OP. Similarly, I will say that any point taken on the tangent, will always be greater than the length of OP. Clear to you all that any point taken on the tangent, I repeat, any point taken on the tangent apart from point P, okay, will always have a greater length when joined to the center of the circle. So I say OQ is longer than OP since it is extended till the tangent that is outside the circle. The same thing which I repeated right now, since this happens for every point on the line XY except the point P, OP is the shortest of all the distance of the point O to the points of XY. Agreed? Perfect. So OP is perpendicular to XY. Then hence I say OP is perpendicular to XY. I am sure that you all will be clear right now with this particular tangent, and we are good to go to apply this particular theorem in the coming applications that will give you a clear idea how to use this theorem when we are solving sums related to this particular chapter. I hope you all are enjoying the session, enjoying the presentation, and having a constructive time with me here. So let's understand it with the help of an application. Now, reading the sum, a tangent PQ at a point P of a circle of radius 5 cm meets a line through the center O at a point Q so that OQ is equal to 12 cm, and we have to find the length of PQ. So, every time in the sum, we may diagram, or we will be lucky enough that they provide us with a diagram. So here, in case if they have not provided with a diagram, we know that P is the point. We know a tangent PQ at a point P of the circle of the radius 5 cm meets a line through the center O. Now we know we have to draw a circle which should be of 5 cm radius from the point O. So we say that O is the center, OP is the radius, and PQ is the tangent. Is it clear to you all? Now, that particular point Q, why? They have not given us any detail about that point Q, where should it lie on the tangent. But yes, they have given us the clue that when we draw a line from the center of the circle, to the tangent which is outside the circle, that particular point will be 12 centimeter away from the center and will be marked as Q. Now I'm sure that you are clear with this particular diagram, how we have converted the question in the diagrammatical representation. We use the theorem that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So we say that angle P, or I will say angle OPQ, angle OPQ is nothing but 90 degree. Once we have a right angle in front of us, what is the thing which will help us to calculate the missing value? Correct, it will be Pythagoras theorem. So can you guys tell me what will be the equation of the Pythagoras theorem, which is the hypotenuse? Angle QPO is the right angle triangle. Okay, quickly tell me what will be the hypotenuse, what will be the one side and the other side. I'm sure that you guys will be done with the calculation as well till now, since it's a very basic thing. So we start with it. OQ is our hypotenuse, OP is the radius, so the one side of the triangle, and PQ is the tangent, that is the other side of the triangle. So we say that OP square plus PQ square is equal to OQ square. Substitute the values. We have OP's value, we have OQ's value, we have to find out PQ's value. Let PQ remain on the left hand side, make it a subject, and then we shift on. While shifting on the sides, or while changing the sides of the numbers, don't forget to change their signs as well. Okay, so when 5 moves from the left hand side to the right hand side, make sure you are changing its 12 square minus 5 square, which is nothing but 144, minus 25, which gives us 119. Now 119 is not a perfect square, so we say that the value of PQ is nothing but under root 119. So the length of PQ is the option D, under root 119. So I am sure that you have understood this particular theorem, that where to use this, and by using this theorem we were able to apply the theorem of Pythagoras and find out the value of the length, the length of the third side of the triangle. I hope everyone is clear with this. Everyone, perfect. Coming back to the word tangent, as I told you, it is a very important term. You listen to this term everywhere, every now and then, whenever you are studying circles. So key points to remember for tangents. The first key point: no tangent can be drawn from the point lying inside the circle. Keep a circle, keep a bangle in front of you, try, or keep a coin in front of you, or keep any circular object in front of you. Mark any random center, try drawing a tangent from that particular side. It is practically impossible. You will not be able to draw a tangent from any point inside the circle. Maybe the center or anywhere inside the circle. Okay, so one and only one tangent can be drawn from a point lying on the circle. As we have seen here, say we take this example. Now from the point P, whenever we have P is a point on the edge of the circle, only one tangent can be drawn from that particular point. No other tangent can be used to can use that particular point to touch the circumference or the edge of the circle. Third point, only two tangents can be drawn from an exterior point to a circle. Now this third point I'll be explaining you with the help of a theorem which will be coming in my following slides. So again, that same feeling, what theorem will be next? Which will be the next theorem? Let's come across the next theorem, that is the length of the tangent, which we were just talking about. The third key point to remember is nothing but that from a given exterior point, let me get it that way, from a given exterior point, that means any point lying outside the circle, not in the circle, not on the circle, any point lying outside the circle is an exterior point. Now whenever I have an exterior point, the number of tangents that can be drawn from that exterior point is only 2. I can use that particular point to draw only 2 tangents to this given circle. Okay, not more than 2. You can draw 1, you can draw 2, but not more than 2. Now whenever you draw these tangents from that particular given point, you will see that the length of the tangents is always the same. Okay, you will always come to that point. Whenever you measure the length of both the tangents drawn from that exterior point to the circle, you will always find out the values to be equal of those particular tangents drawn. Understanding this, the length of the segment of the tangent from an external point to the point of contact with the circle is called the length of the tangent. Theorem related to it, we join OA, okay, we join OA here and we join OB here. OA is equal to OB. Can you tell me the reason? Yes, they are the radii of the circle. OA is equal to OB since they are the radius of the same circle. Now, when to use radius, when to use radii, whenever you have one line starting from the circle, center of the circle, ending to the circumference, only one line, okay, not more than one, we say it is a radius. Singular form is radius, plural form is radii. So we use your radii since we have two radius. The length of tangents from an external point to the circle are always equal. This is the theorem. Now let us understand the proof, the application of this particular theorem with the help of an application. Now we have a circle, okay. From the point Q, the length of a tangent to a circle is 24 centimeter. And the distance of Q from the center is 25 centimeter. Find the radius of the circle. So we say O is the center of the circle, QT is the tangent of the circle. Just ignore that particular diagram. I'll just make sure that we ignore that particular diagram for this sum. Okay. I'll just ignore that particular diagram. So coming back to the sum, just give me a minute, I'll just rectify my mistake. All right, we are good to go with the slides again. Perfect. We again start with this thing. From a point Q, the length of the tangent to a circle is 24 centimeter. The distance of Q from the center is 25 centimeter. Find the radius of the circle. So we have a circle. Let me draw it for you all. It will give you a better idea of what I am talking about. So I'll draw it for you all. Now we have a circle. Okay. Then we have a point. We have a point outside the circle. The length of the tangent to a circle is 24 centimeter. I'll mark Q point here. I'll use my lines. Okay. I'll be inserting a line. And I will draw it right from this point and extend it to the circle. Likewise, I will draw another line from that particular point to the edge of the circle. I hope you are understanding how to draw the diagram as well. Now, reading the question again, from a point Q. Okay, from a point Q, I'll just no fill it so it will give you a clear image. Sorry. Now, when we see the point on the circle. Okay, so this is the point Q. Let me just draw it for you all. This is the point Q. Okay, the length of the tangent to the circle is 24. So I say this is 24. Okay, all right. From the center is 25. That means if this is the center, okay, that means if this is the center, I'll draw another line to the center. I'm drawing another line to the center. Now, when I draw another line to the center, I'm naming it, I'm measuring it to be 25. I hope everyone is clear with the diagram and the sum as well. I'm writing 25. So 24 is, sorry, just I'll erase it. Okay, I just read the question incorrectly. Now, from a point Q, the length of the tangent to the circle is 24, and from Q, the center of the circle is 25. Okay, so 24 is the side and 25 is the hypotenuse. When I draw the radius, I am now drawing the radius from the center of the circle. This particular line which I've drawn in the last is nothing but the radius. Correct? Yes, it's the radius. Now, we use the theorem the tangent at any point of the circle is perpendicular to the radius through the point of contact. Okay, let's start with the explanation now. How will you find the radius? We have to find the radius. We'll use the measurements. We name that particular point as t. So ot square plus tq square is equal to oq square, where ot is the radius and we have the remaining two values. We substitute those values. 25 square minus 24 square, that is nothing but 625 minus 576. So we have OT square is equal to 49 and OT is equal to under root 49, and 49 is the perfect square of 7. So we say that the length of the radius for that particular circle is 7 centimeter. I am sure that you guys are completely understanding this particular thing, how to use Pythagoras. Now, how we did use Pythagoras? We use the tangent theorem. Here we can say that OT is as well equal to the tangent which is drawn on the bottom side of the circle. So we can use both the theorems here to make sure that we are understanding the application of both the theorems. Moving forward to the third sum. Now, two concentric circles. There are bright chances of the board asking you questions with respect to two concentric circles. Whenever I talk about two concentric circles, that means एक circle होगा बाहर और एक circle होगा अंदर. As you can see it on the diagram, two concentric circles. I am sure that you all might have eaten or tasted that rings, okay, the corn rings or the garlic rings, okay. That is exactly what concentric ring circles is all about. The one is the outer circle and the other is the internal circle. Find the length of the chord of the larger circle which touches the smaller circle. So we have drawn two concentric circles. Now we draw the radius for the smaller circle, that is OR, and we draw a triangle. We draw the radius for the outer circle. We draw the radius for the bigger circle, that is OP and OQ. I repeat again the drawing. We join OR. Correct. So we have joined OR, that is nothing but the radius for the smaller circle. We join OP and OQ, that is nothing but the radius for the larger circle. And when we join PQ, we see that at point R, it is forming a tangent to the inner circle with the center O. Alright. So given details, we have OP is equal to OQ, which is 5 centimeter. So now this is the exact presentation which we have to use in your paper. Given details always to be mentioned. What is to be found out? Next question. And don't forget to mention why the given details is equal or are equal. Why? Because these mentioned details will also carry marks. Whenever you are scoring full, all these minute things will allow the examiner to cut your marks. So OP is equal to OQ, that is nothing but 5 centimeter. OR is 3 centimeter. And OR is perpendicular to PQ by theorem. Now I am sure you will be able to use the theorem. Which theorem we are talking all about? We are talking about the 13.1 theorem of your NCERT or 12.1 theorem of your NCERT. That is, the tangent drawn to any point on the circle forms a perpendicular with the radius, correct? So we have the given details. Now, considering triangle OPR and OQR. Considering triangle ORP and ORQ. We prove them congruent. How to prove them congruent? It's very easy. We say OR is the common side. We say angle ORP and ORQ are 90 degree. Since we have already understood that by that it is perpendicular. So every perpendicular forms a 90 degree. Absolutely correct. And we say OP is equal to OQ, the radii of the same circle. Perfect. So we have proved the said triangles, that is triangle OPR is congruent to triangle OQR by RHS congruency. Whenever we use 90 degree, we will mention the test of congruency to be RHS, that is right hypotenuse and side, that is right angled triangle. PR is equal to RQ. Once we prove the triangles congruent, can we say that the third side, that is PR is equal to RQ, will be equal by corresponding parts of congruent triangles? So just make sure you write the full form. Here I've used a short form. You have to write the full form of CPCT, that is corresponding parts of congruent triangles. I am sure you are clear till here now. Now what we have to find? We have to find the chord, that is the PQ. We have to find PQ here. How to find PQ? We'll use Pythagoras here again, since we have proved 90 degree. So PR square plus OR square is equal to OP square. I've used triangle OPR. You can use triangle OQR as well to use Pythagorean. Okay, either of the two will work. We get the values, we substitute the values. OR is the shorter radius, so we take it as 3. OP is the radius of the larger circle, which is nothing but 5. These two details are always given in the question. So we subtract the squares of both of them. We get the answer as PR is equal to 4. Now the question is not complete yet. We have to find the total length. Okay, we don't have to find the length. We have to find the length of the chord of the larger circle. So we say PQ is nothing but the addition of PR and RQ. So we add them. 4 plus 4 is equal to 8 centimeters. So this is how we apply the given theorems in the given sums. Now these all are very important sums, as they involve the basics and they keep on advancing. The basics are the same. The core is the same. You have to use those theorems, but in different manner. Moving on to the next part. Now this sum will help you understand what is an angle in a semicircle. Perfect. So we read the sum. This sum we'll understand about whenever we are talking about a circle which is circumscribed by a triangle. We'll be using here the theorem 1 as well. We'll be using here the theorem 2 as well. That is 90 degree wala theorem. And we'll also understand that the tangents drawn from a given point are always equal in length to the circle. Reading the question, a triangle ABC is drawn to circumscribe a circle. Now there's a circle. Now whenever a triangle is circumscribing, that means the circle is an inscribed circle in the given triangle. So this is an opposite manner. This is a slightly twisted manner to given in the question. A triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and CD, into which BC is divided by the point of contact D, are of lengths 8 cm and 6 cm respectively. Find the sides of AB and AC. Now this is the question. Now let us first draw the triangle. So we have the circle circumscribed by a triangle, or we can say we have a triangle inscribing a circle. Clear? O as the center of the circle, ABC is the triangle drawn to it. Now the given details, they've already told us that 8 centimeter is the BD and BE. Okay, let me completely draw the diagram. Now I have named the point where the tangent, where the line AC is drawing a tangent, where the line AB is acting as a tangent, where the line BC is acting as a tangent. So all the three I have proved by theorem that they are equal. Which theorem I am talking about? I am talking about the first theorem, that is a tangent is always perpendicular to the radius. So BD is equal to BE, that is 8 centimeters respectively. CD is equal to CF, that is 6 centimeters respectively. I consider the values of AF and AE to be X. So we say AF is equal to AE is equal to X centimeters, again by theorem. Now I'll again repeat that thing. Here we are connecting the dots, we are connecting the lines with the center of the circle, as the given detail says that the radius of the circle is 4 centimeter. So we join OF, we join OE, we join OD, and from all the vertices of the triangle we join straight lines. So we can see that three triangles are formed here. One is AOB, one is AOC, and one is OCB. I again repeat, one is AOC, another one is AOB, and the third one is BOC. So these three triangles are drawn by connecting the dots to the center of the circle. Moving forward, in triangle ABC, now what is chota a, chota b, chota c? This is nothing but here we'll use Heron's formula. What is Heron's formula? First we'll have to find the S, that is nothing but representing all the addition of the sides divided by 3, the average. So S is equal to A plus B plus C is equal to the whole divided by 3. I again repeat, S is equal to A plus B plus C, the whole divided by 3. That is the first step to use or to calculate the area of the given triangle through Heron's formula. Now ABC, what are ABC? Side BC is, I've taken it as A, that is 8 plus 6, 14. Side B, side representing the letter B is nothing but x plus 6, that is AC, and side representing C is nothing but x plus 8, that is nothing but AB. So C is AB, B is AC, and A is BC. Clear with this? When I solve this, I get the answer to be x plus 14. Now, using Heron's formula, make sure that under root is for the whole equation. That particular under root is for the whole equation. So we say Heron's formula mein s ka value we have to substitute. After substituting, I repeat, after substituting, you'll get the answer as 48x multiplied by x plus 14 in the bracket centimeter square. So this is complete area of triangle A, B and C. I again repeat, we have used Heron's formula here, that is S bracket open S minus A bracket close bracket open S minus B again bracket close, and in the new bracket S minus C. The whole equation is under root. The whole expression is under root. Substitute the values which we have used in the previous slides. We get the answer as 48x the whole multiplied by x into x plus 14 centimeter square. Moving forward with this sum, what is area of ABC? As I have told you, I have joined the dots. I have joined the dots with the center of the circle. We have three triangles. We have added the area of the three triangles. Since the three triangles are inside the triangle ABC, we add the area of all the triangles. Now, what is the formula for the area of triangle whenever you have a height or whenever you have one angle as 90 degree? It is a right angle. So we can use the formula as half into base into height. Here we have the base, we have the height, we substitute the values, and we come to the conclusion that the area of the triangle ABC is also equal to 2 into 2 bracket open x plus 14. When you substitute these values, okay, here I have substituted A, B and C. Okay, I have substituted A, B and C in place of base. The height is same, that is the radius of the circle. So for all the bases, I have substituted their respective values A, B and C. Don't substitute the values of A, B and C. Take 2 as common, so you get 2 bracket open A plus B plus C. And in the last step, substitute the value of A plus B plus C, which we have found out here, that is x plus 14. Going back again to that slide, we get the area of triangle ABC as 2 bracket open A plus B plus C. That is nothing but 2 the whole multiplied by 2x plus 14. Putting it in an equation form, solve this thing, that under root. Now, if you notice that under root has shift onto the right hand side, and whenever the root changes its position, so on the other side we do the squaring of that particular term, squaring of that particular expression. So 4 ka square has become 16, is nothing but 16. So 16 bracket open x plus 14 the whole square. Now, don't use the identity of A plus B the whole square here. Okay, we see similar terms and we have multiplication on either sides of the equation. So we straight away strike off x plus 14 on the left hand side and x plus 14 the whole square on the right hand side. So we come to an equation as 3x is equal to x plus 14. Use the algebraic expression, find out the value of x. Once we have the value of x to be 7, we use that value for AB and AC. That is nothing but AB is equal to x plus 8, which is nothing but 15. AC is equal to x plus 6. So 7 plus 6 is 13. So this is how we have calculated the values for the sides AB and AC. And the third side we already have it in the question, that BC is equal to 14 centimeters respectively. This is a very important sum. Make sure you are revising this sum. Okay, make sure you practice these kinds of sum which involves all the properties, all the tangent theorems, okay, as well as the involvement of Heron's formula for calculating the areas. We quickly go about the sum once again, okay, right from the scratch. Just make sure you are able to recollect the whole explanation, okay. So we have a circle with the center O circumscribed by a triangle A, B and C, and the center of the circle is marked as O. We have proved this by theorem. Writing the values respectively, we get the value of BC, we get the value of AB and AC in terms of x. Joining the dots, we join them and mark them as 4 centimeters since the radius is given us as 4 centimeter. We use Heron's formula. We substitute the values of A, B and C to find out the average. Then use that particular average in the Heron's formula and we come to a conclusion for the area of ABC. Another way to find area of ABC is we use the areas of the three different triangles formed by joining the vertices with the center of the circle. Using normal mathematical expression, both the areas are equal. Of course, they are of the same triangle, so they will be equal. We come to a conclusion. We find out the value of x to be 7 and AB is nothing but 15 centimeters. AC is nothing but 13 centimeters. I am sure everyone is clear with this particular sum, how to use the applications, how to use those theorems in one sum. We have used almost all the properties here in one particular sum. Is it absolutely clear to you guys? Alright, we have one more important theorem coming up. I have seen in my teaching career many students not understanding what is alternate segment theorem. What do you mean by an alternate segment theorem? So here I'll give you a very easy trick to remember alternate segment theorem. I am sure you all will be having excitement on your face to understand this theorem again, because many of the time students are unable to figure out in the given diagram that where, when, how we calculate calculate the values of angles using this particular theorem. So the alternate segment theorem, also known as the tangent chord theorem, states that in any circle the angle between a chord and a tangent through one of the endpoints of the circle is equal to the angle in the alternate segment. Now we have a line passing through the circle, touching the circle, that is the tangent. Now that's 74 degrees. If you see on the screen, 74 degrees given in pink is equal to the angle on the top right side of the circle. Now this 74 degree is forming an exterior angle with the triangle. It is an exterior angle with the triangle with the tangent. So now this tangent and the chord inside the circle is coming to be equal by using this alternate segment theorem. Let me explain you with the help of the theorem. I'll read one by one and I'll explain you with the help of the diagram. The alternate segment theorem, also known as the tangent chord theorem, states that in any circle the angle between a chord and a tangent. So this is the angle between the bottom 74 is the angle between the tangent and the chord. All the three sides of the triangle are the chords, right? So the angle is formed between the tangent and the chord, that is 74 degrees, and is through one point of the endpoints of the chord is equal to the angle in the alternate segment. Which is the alternate segment? The next vertex. This is one chord, this is the other chord. This is one segment, this is alternate segment. So this angle formed with the tangent and this angle formed between two chords will always be equal. I am sure that you are clear with alternate segment theorem. You can do the same for 51 degrees as well. Now 51 degrees is forming here with the tangent and this is the chord inside the circle. This is another chord inside the circle. So we say that this angle formed is also equal to 51 degree. Alright, are you guys clear with it? Are we good to go? We will be solving a sum so that you are clear how to use alternate segment theorem, where to use alternate segment theorem, when to use alternate segment theorem, how does it help us to find out the missing values. So in the given figure, O is the center of the circle, PQ is the tangent to the circle at point A. So we take O as the center of the circle, A is any point on the circle, PQ is the tangent of the circle. So here O we have taken as the center, PQ is the tangent. Where the tangent is touching the point, we mark that point as A. PAB, I again repeat, angle PAB's value is given 58 degrees. We have to find out angle ABQ and angle AQB. So let us start with the sum. First, write the given details. O is the center of the circle, PQ is the tangent, OB and OR are the radii. Now why radii? Because there are two radius, so plural form of radius is radii. and angle PAB is equal to 58 degrees. Now, angle in a semicircle. BR is the diameter, BAR will be 90 degree. As we have already understood the theorem of angle in a semicircle, that any vertex which joins the diameter, which joins the vertex of the diameter, and that particular point is on the edge of the circle, we say that it is equal to 90 degree. Is this much clear? Then we say ARB is equal to PAB, alternate segment theorem. When I am talking about alternate segment theorem, again you can see this is PA, this is PB. Everyone can see my actions. This is PA and this is PB. Sorry, this is PA and this is AB. All right, this is 58 degrees. Now, this is AR. In extension to A, inside the circle, I have drawn AR. Now, ARB will also be equal to 58 degree by alternate segment theorem. Yes or no? So, I am sure now you are clear of how to use the alternate segment theorem. So, we say PAB is equal to 58 degrees. ARB is also equal to 58 degrees by using the alternate segment theorem. Moving forward, ABQ. ABQ. Now, what is the value of ABQ? How we'll get that? The sum of angles in a triangle is 180 degree. I am sure that everyone is aware 180 degree is nothing but the sum of all angles of a triangle. Yes, so I've used that formula here. Angle ABQ is equal to 180 minus 90 plus 58. Now angle A is 90, angle ARB, angle BAR is 90, angle ARB is 58, and we will find out ABR simply by using the theorem of angles. The sum of all angles in a triangle is equal to 180 and the value of ABQ is 32 degrees. Moving forward, same way as we do it for RAQ, we do it for RAQ. Alright, 180 minus 58 minus 90. What is the value we get? We get that value as to be 32 when we use the triangle BAQ. And BAQ plus AQB plus ABQ is nothing but 180 degrees. So 122 degrees plus AQB plus 32, we get the value of AQB as 26 degrees. So we have successfully found out the value of AQB as 26 degrees and ABQ as 32 degrees. Is the sum absolutely clear to each and everyone here listening to me? Yes or no? Alright, perfect. So, I am coming up guys with a special class. That's all with circles for today. I am pretty sure that it will be a summary lecture for all the theorems which we have understood. All the theorems, okay? Now, let me brief you all with the special class steps. You have to download the Unacademy learning app. Select the CBSE class 10 goal, okay? Type it in the search goal or scroll down in the app. You will get CBSE class 10. Click on that particular thing. Select your preferred language as English. Type Vinay Bajaj in the search bar. Select my profile and you will be able to see which all special classes or what all special classes I am going to conduct today or in near future. Follow me there to get notified with all my special classes. Today, that is May 24 at 2 o'clock, I am coming up with quadratic equations, NCERT solutions of important questions. Enroll there for free. I will see you all at 2 o'clock. As well, make a note that I'll be having free sessions for you all on 26th and 27th on the Unacademy portal, and on 29th again I'll be live on YouTube for you all with a special quiz. Okay, we'll be having a live quiz. So stay tuned with me and thank you so much. Thank you so much for being there in the session. It was an amazing session. Hope you found it very helpful for you all. If you liked it, if you liked watching the video, you understood all the presentation, all the theorems, don't forget to subscribe Unacademy. You can use the referral code for a 10% discount. Thank you so much guys. Have a wonderful day. Stay safe. Stay indoors.